Welcome to Resolution Proof in Predicate Calculus. This is Dr. Teo Kim Heng, Informatics Academy. Last lesson, we have studied resolution principle with RAA for propositional logic. Today we are going to extend the proof technique to predicate logic. Well, there are some difficulty in extending the proof technique. For example, handling quantifier. Here we assume that existential quantifier already been replaced by Scholemization function. Therefore, we can assume that all the variables in the premises are universally quantified. We are going to use the following stakeholder case study to demonstrate the use of resolution principle and RAA. In this case study, there are 6 rules and facts in the premises. There are 4 predicates: work, lead, supervisor, and stakeholder. Those terms that start with lowercase, such as Peter, John, Alan, and AI, are constant. Therefore, we can assume that there are at least 4 constant objects, Peter, John, AI, Alan, AI, in the universe. Those terms that start with capital letters, such as person, project, P, represent variable, and all the variables are universally quantified. For example, the first rule says that if a person works for a project, then the person is a stakeholder of the project, and this is universally true for all person and project. The second rule says that if a person leads a project, then the person is a stakeholder of the project. Third rule says that if P is a supervisor of person and the person is a stakeholder of project, then P will be a stakeholder of project. Note that the third rule is a recursive rule. It defines stakeholder in terms of stakeholder. The query for the stakeholder case study is: who are the stakeholders of which project? And the challenge is to find all solutions to the query, not just one particular solution. So we need to use a systematic way to search for all the answers. This is a relatively small case study, so we can manually find all the solution. For example, we know that Peter worked for AI, and according to rule 1, Peter will be a stakeholder of AI. Similarly, we know the fact that John lead AI. So according to rule 2, John will be a stakeholder of AI. We also know the fact that Alan is a supervisor of Peter, and Peter is a stakeholder of AI. Therefore, under third rule, we can conclude that Alan is a stakeholder of AI project too. So altogether, we have 3 solutions. Before we discuss the detailed step in using resolution principle with RAA on the stakeholder case study, let's try it out using 3 Prolog. As explained, Prolog is a programming language where the processor is using resolution principle with RAA behind the scenes. This is a Prolog code In Prolog, cordon hyphen stand for if. So here, the first statement should be read this way. If person work for a project, then he will be a stakeholder of project. The full stop is the end of the first clause. So we got 1, 2, 3, 4, 5, 6 clauses. And our query is who are the stakeholder of which project. So we visit Sui Prolog according to this URL. We enter the product code on the left panel. We enter the query on the bottom right corner. And then we click the Run button. Prolog will give the first solution to the query. Here, if who is replaced by Peter, which is replaced by AI, you will get an empty clause. In other words, Peter is a stakeholder of AI. If you click the next button, Prolog will give us the second solution. John is a stakeholder of AI project. If you click the next button again, Prolog gives us the third solution. Alan is a stakeholder of AI project. If you click the next button again, Prolog responds with false, indicating that there are no more solutions. So Prolog successfully found 3 solutions for the stakeholder case study. The given rule and facts are already in glossar form. But if you are not comfortable with implication operator, you can remove the implication. We know that A implies B is equivalent to not A or B. So the first rule, work implies stakeholder, can be replaced as not work or stakeholder. Second rule, lead implies stakeholder can be replaced as not lead or stakeholder. Similarly, the third rule, we can remove the implication and get the glossar format as C3. The RAA requires us to negate the goal. So the goal is who are the stakeholder of which project. We negate it, and it's already in the glossar format. So altogether, we got 7 clauses to process, and our job is to find all possible way to get empty clause. The way that Prolog found all the 3 solutions is called full resolution tree. The tree starts with the negation of the goal, because our query is who are the stakeholder of which project. So the negation of the query or the negation of the goal is clause 7, not stakeholder who which. Prolog tried to resolve the current clause so that it can become an empty clause as soon as possible. So in order to resolve with not stakeholder, Prolog need to find a clause with positive stakeholder predicate. It finds 3 clauses. Clause 1, clause 2, and clause 3 all have positive stakeholder predicate. However, clause 1, the stakeholder, the parameter are person and project. In clause 7, the stakeholder predicate parameters are who and which. These two predicates are not identical, but they are different in the parameter, and all the parameters are variable, and variable can substitute each other without any problem. So for example, we substitute who with person, which with project, then this negative stakeholder who which will be able to cancel with stakeholder person project, and the resolvent is not work person project, and we call the resolvent C8. Similarly, C7 can resolve with C2, and the resolvent is not the person project. C7 can be resolved with clause 3, and the resolvent is not supervisor, not stakeholder altogether. The resolvent C8 can be resolved with C4 because we have a negative work paired with positive work. Variable person can be substituted with constant Peter. Variable project can substitute with constant AI. And after this substitution and resolve it, the resolvent is an empty clause. The empty clause gives a first solution when who is substituted by person and further substitute by Peter, and which is substituted by project and further substitute by AI. We reach an empty clause. In other words, we conclude that Peter is a stakeholder of AI. The resolvent C9 can be resolved with C5 because the not lead can cancel with lead, and the variable person can substitute with constant John. Variable project can substitute with constant AI. And in this way, negative lead and positive lead will cancel each other, and the resolvent is an empty clause. And we conclude that John is a stakeholder of AI. This is the second solution we found. The resolution for C10 is a little bit tricky because it has two negative predicates. Prolog will try to change each one to empty clause one by one. So it will try to resolve not supervisor first. After searching, Prolog finds that C10 can resolve with C6, supervisor Alan Peter, by substitute P with Alan and person with Peter. So, at the end, the person will be replaced by the constant Peter, and the project remain a variable. So the resolvent is not stakeholder Peter project after the resolution. If we look at clause 11, we will notice that it is very similar to clause 7. The only difference is in the first parameter. Well, in clause 7, the first parameter is person, which is a variable. And in clause 11, the first parameter is Peter, which is a constant. Therefore, clause 11 is more specific than clause 7. And therefore, the search will be more narrow. Nonetheless, clause 11 still can resolve with clause 1, clause 2, and clause 3. For example, clause 1 had a positive stakeholder can cancel with the negative stakeholder in clause 11. And the first parameter variable person can be unified with Peter, and project can be unified with project. Notice that we rename the variable in clause 1 before we perform the resolution. That is to avoid name conflict, because along a same path in the resolution tree, the name person project may be accidentally matched, but it refers to different object. Since the variable in each clause is local to the variable, it's better to rename the variable name before performing resolution. And that's what Prolog is doing. So whenever we resolve with a clause, all the variables are systematically renamed. So we assume in this case, the parameter person is renamed to person 1, project is renamed to project 1. Then perform unification with clause 11. And then we will notice that person 1 is unified with Peter, and project 1 is unified with project. And the resolvent is not work Peter project. Clause 12 can be further unified, resolved with clause 4, not work Peter AI. All we need to do is substitute project with AI. So we got empty clause. Now you look at the path from clause 7 all the way to empty clause. We will notice that at first we got a who. Stakeholder who, which. The who is substitute with P and further substitute with Alan. The which is substitute with project, and project eventually substitute with AI. So therefore, who substitute with Alan, which substitute with AI, we get an empty clause. So Alan AI is another solution. Similarly, clause 11 can resolve with clause 2. Of course, we assume the variable are renamed already. And so person 1 would unify with Peter, project 1 will unify with project, and the positive stakeholder will cancel with negative stakeholder, and the resolvent is not did Peter project. Let me call it clause 13. Prolog try to resolve clause 13. It need to find a clause with positive lead Peter that can match with Peter project. Unfortunately, Peter never lead a project. Therefore, we cannot find a clause to resolve it to this particular clause 13. Therefore, this path end up no solution. And Prolog would perform backtracking. That means backstep, try another alternative. So after backtrack from the previous step, Prolog will try to apply the resolution with clause 3. So we assume that all the parameter has been renamed. And therefore, this positive stakeholder is resolved with the negative stakeholder. And the resolvent is not supervisor, not stakeholder. Okay, so we got a not supervisor, Peter person 1, not stakeholder, person 1 project. And let me call this clause 14. In order to make this an empty clause, Prolog need to find a way to resolve supervisor Peter. But Peter is not a supervisor for any other person in our clause base. or database. Therefore, there is no way to resolve C14 to empty clause, and therefore Prolog backtrack. And eventually, there is no other way in the whole resolution process, and the Prolog will end the search for solution here. This is the full resolution tree. It gives us a picture how Prolog systematically find all the solution to the query or goal. The tree starts from the negation of the goal, and it tries to find all possible ways to resolve to empty clause. Prolog used a top-down, left-to-right method in the searching. Top-down because for example, to resolve with clause 7, not stakeholder, the Prolog find 3 clauses: clause 1, clause 2, clause 3. Because we write clause 1, clause 2, clause 3 in this particular order, Prolog will resolve clause 1 first, followed by clause 2, and followed by clause 3 in this particular order. Prolog actually do a so-called depth first search. That means what? After resolve C7 with clause 1, you got to C8, it will try to resolve with C8. For example, resolve C8 with C4, it get an empty clause, which gives us the first solution. If we look at the path from the root to the first empty clause, we will find the substitution or unification. Who is unified with person, further unified with Peter, which is unified with project, and further unified with AI. So under this final substitution, who replaced by Peter, which replaced by AI, we can reach empty clause. And therefore, we got one solution. Peter is a stakeholder of AI. When Prolog finishes finding the first empty clause, it will backtrack, try to find another alternative. So you apply the second way to resolve with clause 7, which is resolve with clause 2, and further resolve with clause 5, and you find in the second path, you find another solution. John is a stakeholder of AI. After finding the second solution, Prolog backtrack and try to find alternative way to resolve with clause 7. And he find clause 3. And clause 3 is very complicated because it is a recursive one. The stakeholder will resolve with the positive stakeholder in clause 3, but the resolvent still has a negative stakeholder inside there. Now, the resolvent C10 has 2 predicates. Prolog will try to resolve with the first one, and so he need to find a way to resolve with supervisor, and we got one clause, namely clause 6, where Alan is a supervisor of Peter. So when P is substitute Alan, person is substitute Peter, we can resolve with the first predicate. And the person, remember person is substitute with Peter, so the resolvent is stakeholder Peter project. Now, this clause 11 is similar to clause 7, therefore it can still apply resolution with clause 1, clause 2, and clause 3. But bear in mind that in clause 11, the first parameter is Peter, which is a constant. Therefore, the search space will be narrower. So the solution to this one, we will only find one solution for clause 11. That means Peter is a stakeholder of AI. And since Alan is a supervisor of Peter, Peter is a stakeholder of AI, so Alan is the stakeholder of AI. You look at this path from the root along C3, along C6, along C1, along C4. You will find the substitution. Who is substitute with P and eventually substitute with Alan? Which is substitute with project? And project is substitute with project 1, and then project 1 is eventually substitute with AI. Therefore, we got the third solution. Alan is the stakeholder of AI. Prolog tried to find alternative to resolve C11, but unfortunately it failed to get any solution because other alternative need Peter to be a leader of a project or a supervisor of other person. But Peter, in our case, there's no evidence that Peter is a leader or supervisor. Therefore, there are no solution from this alternative path. For the stakeholder case study, the facts such as R4, R5, and R6 can be easily stored in relational database table. Work with 2 columns, storing who worked for which project. The lead table store who lead which project, and the supervisor table store who are the supervisor of which supervisee. If R3 is not included in the model, then queries such as stakeholder who which can be easily solved in SQL. For example, all we need to do is perform the union of these 2 tables, work and lead. However, R3 is a recursive group. It defines stakeholder in terms of stakeholder. Therefore, with R3, queries such as stakeholder who which require a system to find the transitive closure in the supervisor table. For example, we need to find not just the supervisor of Peter, but the indirect supervisor of Peter, no matter how many levels up. It is well known that SQL does not have the ability to find transitive closure. But handling recursive rule is just a basic requirement for logic processor. So logic processor handling recursive rule easily. So we can augment traditional database of facts with a logic processor to handle recursive rule, and the result is called a logic database or deductive database. You can try to challenge a more difficult case study called stakeholder plus. The premise are similar to the stakeholder, except that we have 2 more facts. Peter also lead software engineering project, and Mary supervise Alan. So Peter, in other words, Peter got a direct supervisor Alan, and also has an indirect supervisor Mary. Since Peter is the lead software engineering, we notice that Peter is a stakeholder of software engineering. Alan is therefore a stakeholder of software engineering. Similarly, Mary is also a stakeholder of software engineering, and therefore we should have 7 solutions. You can use Swift Prolog to find the solution to stakeholder plus case study. You should verify that there are exactly 7 solutions. This is the end of today's lesson. Thank you for your participation.